Okay, so having looked at different uses of the type of the struct keyword, let's look a little bit at how we can define custom types using Typedef, right. In some sense, we have already defined custom types. When I declare struct fruit and then say XYZ or of type struct fruit, in some sense I have already created a new custom data type. So what exactly are we trying to do over here, right? What Typedef does is to make it sort of more systematic. It allows you to create arbitrary types that can be declared in a centralized location, possibly in a header file, and used across multiple different parts of your code. And by sort of judicious use of these typedefs, you can make your overall code much more readable and understandable, right. So typedef is effectively a syntax element that allows us to define custom data types. It allows reusability, right. For example, we already saw one case where a struct fruit which is declared inside at the global level and a struct fruit that was declared inside another function were not the same, right. What Typedef would do, if you used it properly by declaring it either in a header file or at the global level, would make it such that everybody is clear about what this particular type is, and you do not have this kind of confusion of having to redeclare types everywhere you want to define a particular element. It would result in cleaner and more readable code, once again if used judiciously. So let's look at a few examples of how we might go about defining typedefs for use, right. In this particular case, all the examples are doing are using typedefs that are declared within a given function scope. But the fact of the matter is that in most cases you are probably more going to benefit from the typedef by having it at a level which is usable across multiple functions, right. But this serves to illustrate the how we can define typedefs, so let's go ahead and take a look at it, right. As you can see, I could have declared something struct d1 which has some field called int x, right, just close that, right. I am not declared a particular variable of that type out here. What I do is I then say typedef struct d1 as d1, okay, and this is interesting. So basically what it's saying is I am typedefing, right, defining a new type. The sort of source data type is struct d1, right, and the new data type that's being created is, again I'm using the same word d1 out here, right. That works because ultimately what I would like is something like what is happening on line 161, which is I just want to declare d1 x, right. Now in this particular case d1 x is quite opaque. It's really a badly written piece of code for the simple reason that I have no idea what d1 is. On the other hand, if I had defined a struct animal or a struct fruit and I then declared fruit x, that is probably actually useful because in some sense it tells me that yes, there is something out here that I need to look up. But you need to be really careful. What this indicates is that you really need to be careful with how you define types. First of all, they should be well documented so that you know exactly where to look for it. The second is it's probably also a good idea to use certain kinds of standard conventions on how you define data types, custom data types, right. In any case, I can declare d1x and I can initialize it at one shot, right. I probably did not even need this typecast, right. It would work with or without the typecast, but that's fine. It has now become, right. What has happened is rather than having to declare struct d1 everywhere, I can just use the word d1 and the compiler knows exactly what I am talking about, which is sort of to again stress the point. Typedef was probably not strictly essential. It was, you could have got around without it, right. What it has done is added some syntactic sugar which makes it much cleaner to write this piece of code. There is less verbosity, less characters on the screen over here that you need to read, and by properly choosing names it can actually make your code a lot more readable and understandable. So what happens anyway when we run this, you will notice that this x over here I have intentionally chosen it to have the same name as this. What it means is I can have a element of type d1 which internally has a field of type int and they both have the same name. X dot x is not the same as x, right, they are different elements. So what happens when I run this? It basically prints out inside x the value is 10, which is what I had assigned out here. Okay. Now what I have done here is I first define the struct, and then the next line I have a typedef struct. I could have done it at one shot instead, right, where what I do is I basically say typedef struct d2 int x, and I give this line d2 at the end, right. So the struct d2 etc. and this d2 out here, the second one is what is important, that is the one that is actually defining the typedef. In other words, everything out here is the source of what your new type definition is, and this d2 is the new type that is getting created, right. So you have a source of a new type and a new type, the name of a new type that is being created, right. So d2y is equal to 20, and what happens is that inside y the value is 20. Now notice that because y is a struct, I cannot just say y is equal to 20, I have to give it within these curly brackets, right. I could probably have done it without this parameter out here, right, because after all I am declaring d2y and also initializing at one shot, but d2y is a struct, it is not just an integer. When I try this, it actually gives me an error right here saying that initializing a struct takes with an incompatible type int. So I do need the curly brackets, and with that the errors go away. Okay, I can shorten this even more and get to the point where basically what I am saying is typedef struct int x d3. What happened? Even this word d2 that was present out here has been removed. This struct and just the immediately starting the curly brackets is what's called an anonymous struct, right. Once again, the whole purpose of this is making your code a little cleaner and easier to understand, right. You don't have some kind of intermediate unnecessary name out here, you don't have extra lines in order to define the struct followed by a typedef. This actually makes the whole type definition quite clean and easy to understand, and when you use it, of course, it behaves exactly as expected, everything is okay, right. Now there are a couple of more sort of strange uses of typedefs that you can come across, which for example we might find that I typedef int as, let us say, my number, right. Remember, int is the source, my number is the name of the new type, okay, and from here onwards I can actually declare my number a is equal to 10, right, and I can now use it exactly the same way I would have used an integer, right, and this works, right. I'll probably just comment the rest of this out. And what we find is when we run that, just this line corresponding to the printf my number works. Now you can do something like this, you have to be very careful with it for the simple reason that this particular definition has done really nothing to improve the readability of the code. In fact, you could argue that it has made things worse, because someone who is looking at this fresh is first of all going to struggle to understand why is there this my number out here and what is my number like, right. And if you do not have this typedef right there to tell you what it is, let us say it is hidden away in some header file, you will probably be thinking, is this an int, is it a char, what is the range, what is the maximum value that I can store over here, can I store fractional values, is it a float, is it unsigned, can I store negative numbers, right. None of those are clear by just having this value my number out here, right. But there are places where it is potentially useful. One of them, for example, is, let us say that you start off by developing your code by saying double, right, and you can of course print it out over here, right, and sure enough it actually prints it out as double, but at some point maybe you find that double is taking too much space, it is 8 bytes per value, I do not really need this for my computation, I could have done it with floats which are 32 bits or 4 bytes. At one shot I can make this change out here, and the behavior in this case at least remains exactly the same. Whether it would remain the same in your particular example would depend, right. But this is a potential use case where you might actually want to define a custom type, because you know that at some later point in time it is going to be replaced by something. You might want to change a double to a float or a float to a double. In particular, when you are doing hardware design, you might come across things where you want to have a custom data type or a new class, which is not really easy to do in C, but something which takes fewer number of bits, right. Or let us say that you are trying to program something for a graphics processing unit and there is a new data type called a 16-bit floating point number. You just need to change it in one place and your code then just compiles and runs. So there are potential uses for redefining existing data types, but the primary use case of Typedef is actually to sort of give better and easier to use names for structs.